Okay, so we're going to learn a little bit more about rotations in this video. We're going to perform rotations on images clockwise and counterclockwise by 90, 180, and 270 degrees, which we learned a little about in the first video. And then we're going to graph the new image on the coordinate plane. So we're going to get more into looking at the coordinate plane with the grid. So what is a rotation? Rotation is when you turn a figure around a fixed point, and we're only going to be dealing with turning things around the origin, which is the center of a 0, 0. Okay? So you've learned how we can turn objects. There are two ways. One way is clockwise, and then the other way is counterclockwise. Again, you might see it abbreviated counterclockwise, CCW, and clockwise would be CW. Okay, you need to know the two D's of rotations. So we've got double D's, and they are direction and then degree. Okay, so I need to know if you went clockwise or counterclockwise for direction, and then I need to know the degree. So was it 90, was it 180, was it 270 degrees? Okay. All right, do you remember the quadrants? Hopefully from middle school or algebra, you've got a coordinate grid, and this is the first quadrant with the Roman numeral, and it actually goes counterclockwise, and here is the second quadrant. The third quadrant is right below it with the Roman numeral of a 3, and then the fourth quadrant is an IV. Now, what do you remember about the first quadrant? What do I know about all of those points right there? I know they're all positive, positive. Okay. In the second quadrant, I noticed that my x's are negative and my y's are positive. That means the third quadrant is full of negative, negative ordered pairs, and that means the fourth quadrant has positive x's and negative y's. So if you remember the signs of the quadrant, this is going to be a whole lot easier for rotations. All right, one more question. After a rotation has been performed, is the image going to be similar or congruent to the pre-image? Explain. So again, pre-image means the before image. Congruent, we know, means equal. And then similar, we've not yet learned, but similar is when they are the same shape but a different size, so kind of like dilations. So why don't you answer that question in a complete sentence, and then we'll go over it. Alright, so I said the image would be congruent because it is the same shape but just facing a different direction. Okay, so translation and rotations and reflections are all going to be congruent, but we know dilations are the only one for similarity because you're changing the size of the shape. Okay. All right, so time for some rules. So when you rotate something, the rule is to switch the x and the y coordinates, so it'd become y comma x, and you're going to check the signs of the quadrant that you're located in. Okay, so I want to rotate triangle ABC 90 degrees counterclockwise and then label it A prime, B prime, C prime. So first off, I'm going to list the ordered pairs of A, B, and C because this is going to be the easiest way for me. So A is at a 1, 1, 2, 3, 4. So 1 comma 4 is the coordinate of A. B is going to be 1, 2, 3, 4, 5, comma 2. And then C is at 0 or 2 comma 0. Okay. So I want to go 90 degrees counterclockwise. So I'm going to move it somewhere over here. One turn, so it's going to be located in this quadrant number 2. And so I need to switch my x and my y coordinates. So I'm going to go ahead and do that. So A prime is now going to be at a 4, 1. B prime is going to be at a 2, 5. And then C prime is now going to be at 0, 2. So now that I switched my coordinates, now I need to check the signs. So I know in the second quadrant, my ordered pair is going to be a negative and a positive. So I need to make sure all my x values are a negative. So go ahead and put negatives, 0 doesn't need a negative sign, and then make sure all your y's are positive. So 1, 5, and 2 are all positive, so I'm good. So now I'm just going to graph it. Now Now go to a -4, up 1, and that's your A prime. Go to a -2 and then up 5. That's your B prime. And then don't go any, but go up 2, and that's your C prime. And then connect the triangle, and then you can see how they went from ABC to A prime, B prime, C prime. They just kind of turn that shape a little bit, like it's kind of turning around this center of the origin. So some things to notice: if it's on an axis, an X or Y axis, it'll just flip to that other axis. So if you have a point on the axis, it's going to flip either up, down, however many turns, but it will still remain on an axis. Okay, so that is the rule when you rotate something 90 degrees. You need to flip your X and your Y's. So now we're going to look at rotating something 180 degrees counterclockwise. And we're going to label it A double prime, B double prime, C double prime. So what that means, I'm going 180 counterclockwise. So I want to make one turn and then turn it again. So it's going to be somewhere down here in the third quadrant. Okay. So first off, let me go ahead and find my A, B, and C. We found that A was at 1, 4, B was at 5, 2, and C was at 2, 0, since it was the original shape. Okay, so let's think about this. If I rotate it once, I flip my ordered pair. So if I had X comma Y, I would flip it Y comma X. Okay, so let's say I flip it again, then I'd be left with X comma Y. Okay, so when you flip something 180, there's no need in flipping it and then flipping it again. Okay, so you don't flip the coordinates when you go 180 degrees. Okay, so my A prime is still going to be at a 1, 4. My B prime is still going to be at a 5, 2. And my C prime is still going to be at a 2, 0. Okay, but I do need to check the signs of my quadrant. So if I move twice, I'm in the third quadrant, which is negative, negative. So I need to make every single one of those numbers negative and 0 is okay. So then I would graph that new shape. So I'm going to erase this so we can get some graphing. So A is at a 1, negative 1, 2, 3, 4. A double prime. B is at a negative 5, negative 2. And then C is at negative 2, 0. Those should be double primes. Okay? So there is the shape rotated 180 degrees. So notice it also looks, if I look at this top one, it also looks rotated 90 because it kind of rotated back down. Okay? So that is the rule for 180 degrees. So let's go ahead and make a rule note. You don't, we'll say we'll keep the coordinates, but check the signs check the sign of the quadrant. So we're not going to flip the coordinates, we're going to keep them the same, but we're going to check the sign of the quadrant that it's in. Okay? So those are the rules for rotating something 90 and 180. So you know the rule for 240. So that is how you write the rule for rotations in words, and we're going to learn a new notation with the symbol. So we've got a capital R this time. Remember the lowercase r stood for reflection, and this is going to stand for rotation, and then you're going to have a subscript below it with a C and then a theta. So C stands for the center, and we're always going to talk about the origin, so notice you're going to have O, 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 O standing for the origin. Now this Greek symbol theta represents a degree, so it's going to be your degree of rotation. So they always assume counterclockwise, and this is where it gets tricky because we like to assume clockwise because we look at clocks all day. And in math, they assume counterclockwise. The reason for that is to create an angle. For example, if you're looking at this obtuse angle here, I'm going to highlight it in red, terrible, but I had to go counterclockwise to create that angle. Okay, so that's why in math they assume counterclockwise because that's the degree you have to get to create an angle. So I'm going to erase this real quick. So it says the blue angle is going to be your positive angle, and that stands for counterclockwise. Okay, the red angle is a negative angle, which is going clockwise. Okay, so to go this way, that would be going clockwise, and then the blue would be going counterclockwise. All right, so if it's positive, counterclockwise, negative, clockwise. So here's what you'll see. You'll see a capital R, parentheses, O, comma, 90. So what that means is you're rotating it 90 degrees counterclockwise, because it's positive, about the origin. Okay, so that's just a new notation instead of them actually saying it in words. All right, so negative 90 would mean to go clockwise 90, so one turn. So you're still rotating at 90, but now you're going clockwise. So the positive and negative tells you the direction, and the number tells you how many turns. Okay, now remember with 180, it doesn't really matter which way we go, because if I'm in quadrant 1 and I move 2 turns, boom, boom, I'm here. If you go clockwise, boom, boom, you're still here. So you could see positive 80, negative 180, they mean the exact same thing. Direction is not going to matter. Okay, now you're probably going to see the first two most common because, again, they like to get you there the fastest. And so 270 we know means 3 turns, because 90, 90, 90 would be 270. So 270 and it's positive is going to mean counterclockwise. So you can go 270 counterclockwise, or if you want to change that rule to going 90 clockwise, totally fine. Okay. So, for example, this rule is the same thing as a rotation about the origin, negative 90. So those rules are the exact same, just written in a different order. Okay. Same thing for negative 270. Since it's negative, that means clockwise. So you can go 270 clockwise, or we know, typo, 90 counterclockwise would be the fastest. Okay. So again, the rule for this one is the exact same as a positive 90. Okay. So these rules mean the exact same thing. And then if you rotate something 360, that just means you're rotating it back onto itself, meaning that your shape is not going to move. Okay? So by far, the hardest part for me especially is to remember that if it's a positive number, that it's counterclockwise. And that's just the opposite of what our brain thinks, which makes it a little bit harder. Okay? So if you see a positive number, you're going counterclockwise, negative clockwise. Okay? All right, so that's a new notation. So you could see it written in words, or you could see it written like this. All right, so you guys are going to try some practice now. Have fun. Let's look at some examples. Why don't you try these? It wants to know the coordinates of something under a degree of rotation. So it might help if you go ahead and draw the quadrant and plot the point and then see what would happen to it. Okay? So let me try the first one with you. So 3, negative 2 would be somewhere down here. Okay, so it's in the 4th quadrant. I want to go 90 counterclockwise. So that's 1 turn counterclockwise. So that will come up here. 1 turn, so it would now be in the 1st quadrant. I know the 1st quadrant is positive, positive, so I know my shine should be positive. But I need to flip my signs. So I need to flip the order fair and then make everything positive. So the new point would be a 2, 3, 4 example. Okay, so why don't you try 2 and 3 now on your own and press pause, and we'll go over them. Got a positive 5, negative 4. So again, negative 5, positive 4 is up here in the 2nd quadrant. 180 degrees is 2 turns, so move it 1, move it 2. So I'm over here in this 4th quadrant, which has signs positive, negative. So I did not have to flip because I went 180 degrees. So I keep 5 and keep 4, but I just need to make sure the x is positive, the y is negative. On 3, you had 3, 2 up here in the 1st quadrant, 90 clockwise would bring it down here into the fourth quadrant, which is positive, negative. Since you went 90, you do have to flip them to a 2, 3, and then you made sure x was positive, y was negative. Okay, so that's how you change coordinates under rotations. So let's look at actual shapes on a coordinate plane now. So 1 and 2 want us to write the rule for each transformation. So you're going to look from going from the original letter to the prime letter. So pick your favorite letter. I'll see Z. And I know that two things could happen, so there could be two rules, but I'm going to write the fastest rule. So the fastest way is to go one turn. So you would say rotated, and one turn is 90 degrees, and then I need a direction. And that direction will be counterclockwise. Okay, that's the fastest way. Now, if I wanted to, I could have gone 1, 2, 3, and that would have been 270 degrees clockwise. Okay, but again, we care about the fastest way to get there. Okay, so that's how you write the rule. Rotated, give me a direction, give me a degree. Okay, so on this second one, why don't you go ahead and try it on your own, pick your favorite letter, and tell me the rotation. Press pause. All right, so on 2 you had 2 turns, so you should have said rotated 180 degrees, and you could have used the word clockwise or counterclockwise. Order does not matter for 180 degrees. All right, now let's look at graphing a shape, okay? Now, it's a little bit harder when the ordered pairs are in 2 different quadrants. So I've got U on the x-axis, I've got Q in the fourth quadrant, and I have P in the third quadrant. So the rule isn't going to apply to everything. So I need to look at an individual letter, see where it's moved to, and then go from there. Okay, so I'll try these with you. So let me go ahead and write the coordinates out. I've got U, Q, and P. So U is on the x-axis at 2, 0. Q is at 1, 2, 3, 1, 2, so 3, negative 2. And then P is at negative 1, 1, 2, 3, 4. Okay, so now I want to go 180 degrees, which means I do not need to switch my x and y pairs. So my U prime is still going to be at a 2, 0. My Q prime is still going to be at a 3, negative 2. And then my P is still going to be at a negative 1, negative 4. Now I need to check the quadrants. So let's start with P. Okay, P goes 180. It moves 1 quadrant, it moves 2 quadrant. So it should be positive, positive. So I need to make sure and go make them positive, positive. Okay, with Q. Q is in this fourth quadrant. It needs to go 1 turn, 2 turn. So it is now sitting in the negative, positive quadrant. So I need to make Q a negative and then a positive. And then U needs to move and go 1, 2. So it needs to sit on that axis over there and be at a negative 2 and a positive 0. Okay? Once you have checked your ordered pairs, now you can go ahead and graph all that work that you did. So U is going to be at a negative 2, 0, and that's my U prime. Q is going to be at a negative 3, positive 2, and then P is at a positive 1, positive 4. All right, so now I've got my shape that was rotated 180 degrees, okay? Yes, this is totally a lot of work, but it's so worth it because you will always be right every single time, okay? All right, so if you're up for it, go ahead and try number 6, and then if not, I'll try it in a second and you can see what I did. But go ahead and try number 6 on your own. Rotation 90 counterclockwise. What I got for the graph of U, X, and R Now let me talk about what I got. So first off, I wrote down all my ordered pairs. Okay, if I'm going 90 degrees, I know I have to flip my coordinates. So I did 1, 4 flipped, 0, 3 flipped, and negative 4, 5 flipped. Then I looked at each individual pair. So U's going to go counterclockwise, so it's going in this direction. So U's going to go from this quadrant to this quadrant, which is negative, positive. So I had to make the 1 negative. X is going to flip up to this y-axis, which was a positive, positive. And then R is going to flip up to this first quadrant, which is going to be positive, positive. So I had to make that for a positive. Then I just graphed them all. Okay. So again, let me know if you have any questions on these. It is a lot more work, I promise, and it's definitely a lot harder because it's hard to see the image being flipped. So you've got 2 challenge problems now. It wants you to do 2 things. So it wants you to draw the final image by rotating it 90 counterclockwise and then reflecting it. Okay, so try A on your own. And then part B, it wants you to draw the final image of reflecting it over the x-axis and then rotating it 90 counterclockwise. So, and then it wants you to know if parts A and B are the same, why or why not. So go ahead and try these on your own, and then press pause and we'll go over what we got. Press pause. For challenge part A, first off, I did the 90 counterclockwise. So I wrote down the order pairs of RST. Clockwise would bring it down here. I flipped my order pairs, and then I made them all negative because this section's negative, negative. So here's my R prime, S prime, T prime. Then you had to reflect it over the x-axis, which is this axis right here. So you're flipping it up. So you have a little bit of an overlap because it was 2 away, so flip it 2 up. T was 3 away, so flip it 3 up, and then R was 4 below, so you flip it 4 up. So you've got a little bit of an overlap up there. But that would be your final image after those 2 rotations. Down here, after you reflect it over the x-axis, I went ahead and did that in my head, and then I wrote down R, T, and S prime over here to then flip that image 90 counterclockwise, because you did have to rotate the numbers. And if you're going counterclockwise, it would move to this quadrant, which was positive x's, negative y's. So I made all my x's positive. I made all y's negative. Okay. So what you notice, these should have double primes. But are the images the same? They are not. Okay. Why or why not? I said no, they're not the same. Reflecting an image and a rotation aren't the same when you reverse the order. Okay, so reflecting something or rotating something and then reflecting it, and then reflecting it, then rotating it, you're not going to get the same image, okay? Which is different from reflections, which we've learned, because we did learn in the past that reflecting it over the x and then the y, that's the same as reflecting it over the y then the x. But that is not the case with rotations. So order does matter with rotations, okay? All right, let me know if you have any questions. Thank you for watching my video, and now you can practice.